So what we have to do, we have to simplify. We have to simplify or equify a big circuit in a smaller one. That's why this is called equivalent circuit. That means this is a simplification. Otherwise, we won't be able to analyze the circuit. Okay. So normally, our circuit will come on. Normally, our circuits will be like this. Okay. Let me go at the end of our lecture. Let's say like this. Our given circuit will be like this. This is a very small, very small power system. 2 bus only. Bus 1. This is bus 1. This is bus 2. 2 bus power system only. Just only. This is unimaginable because this is not real. Because this small simplified small power system is not real. Okay, but for calculation and for understanding, that's why we are here. Normally the power systems are very big, 14 bus, 30 bus, 33 bus, 100 bus, even 200 bus even. Okay, so 2 bus power systems are not real, but these are studied for their simplification, and because they are easy to understand, that's why they are given in the questions. Okay, so we are given with a circuit like this. Then we have to we have to expand, or we have to use the equivalent component here. This is the transformer, and this is the equivalent circuit of the transformer. This is the transmission line. So we have to replace that with the equivalent circuit of the transmission line. Then we have another transformer. We have to give the equivalent circuit of the transformer. Then we have a generator. We have to give the equivalent circuit of the generator. Then we have a load, equivalent circuit of the load. So this is the detailed equivalent circuit of our power system, or a one-line diagram. This is called one-line diagram. Remember this, one-line diagram. Sometimes it is called OLD, one-line diagram, or sometimes it is called single-line diagram. This diagram is called one-line diagram or single-line diagram. One, O-N-E, one. That is one line. Okay. So we have to convert this one-line diagram to our equivalent circuit. Then what? Then we have to simplify this by neglecting the core loss of the transformer. Then we can further simplify these, and we can get something like this. Okay, we can get something like this. This diagram is called simplified impedance diagram. This diagram is called reactance diagram. What? Reactance diagram. Remember this, reactance. So finally, we started from here. See, we started from here. Then we have gone there. Then we ignore some of it. 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 Then finally, we got simplified impedance diagram. Then we got final reactance diagram. This is our most simplified position. Got it, everyone? So I will show you how we have done that, but you have got it, right? Hello? Hello?
No, sir.
Yes, sir.
Yes, sir.
Okay. Now, this is another single line diagram. Again, we have to convert these to our what? Detailed equivalent circuit. Detailed, I said detailed. Detailed means everything you have to mention. Detailed equivalent circuit. Then we have to neglect some of it. We have to got the impedance diagram. Then we have to got reactance diagram. So 3 things you have to do. 3 things you have to do. Number 1, detailed equivalent circuit, impedance diagram, reactance diagram. So why this is called impedance diagram? Why this is called reactance diagram? Because here you can see there are some resistance, right? And some inductance. Resistance and inductance both become impedance, right? What is impedance? What is impedance? Impedance is Z, right? Z is equal to what?
R plus
JX, right? That is called impedance. What is reactance? Reactance is only X, right?
X.
Reactance is
Yes,
only X. Understood? That means when
yes,
your Z is equal to only X, you can call it what? Reactance diagram. Understood?
Yes,
So
sir.
simplified equivalent circuit. This is simplified impedance diagram. This is simplified reactance. You do not have to say simplified. This is just reactance diagram. Got my point? Okay.
yes, sir.
Okay. You may not know how to go from here to here, but that's okay because I haven't teach you that yet. We have just seen some equivalency. Again, equivalent circuit like this. Okay. Again, from here to here, then here, then here. Yeah, this is the final impedance diagram. Reactance diagram, not impedance, reactance diagram. Again, this is a 3-bus system. You have to do. Then you have to stop here. Okay. There are few examples are here. You can practice. I'm going to give these. Okay, did I give these notes to your classroom? Okay, let me check. No, didn't, right? I didn't. Okay, I will give today. Okay. So let's start from the beginning. At first, equivalent circuit of a synchronous generator, alternator, or motor. Okay. At first, we have to know what is the equivalent circuit of synchronous generator, that means alternator, or motor. So the equivalent circuit of a generator or a motor is like something like this. Okay. So you will have a voltage source EG. EG is generated EMF at no load due to the field excitation. This is your EG. Then you have a XAR, this one. What is this? Reactance due to armature reaction, known as frictious reactance, right? But you know it, armature reaction, you know it, right? Reactance due to armature reaction. This is AR, armature reaction, AR, XAR. XL, the reactance due to the leakage flux, known as leakage reactance. Okay? Leakage reactance, right? Okay. I am suffering from cold, so that's why you might find some of my pronunciation are what is that? Banglaয় বলে জড়িয়ে যাওয়া, তাই না?
Yes, sir.
Okay. So this is due to the leakage reactance or leakage flux known as leakage reactance or Portier reactance, right? Now,
Yes,
RA, this one is the resistance. The resistance due to the armature windings known as armature resistance. Now, VT is the terminal voltage, this one, terminal voltage of the generator. VS is the supply voltage of the generator. That means this is a motor. Because this is at that side, that means this is a motor. So you are giving some current here, and VS is the supply from the generator, and it is going to the motor. EMF, EM is the back EMF. Motor always have a back EMF, right? EM is the back EMF. Actually, this is the voltage of the motor. Finally, in simple word, this is the voltage of the motor. Understood? Okay. So you just remember these. Okay, you have a R, you have a XAR, you have a XL. Okay, and you have a EG. So I will explain what these are needed, why they are needed, and what are these. Now, if I told you to simplify this, if I have told you simplify this, then what would you have done? You could add these two, right? Because they are series. Can you add these two? Hello?
Yes, sir.
Okay. You can add these two and call it XS. XS is equal to XAR plus AXL, RA. Again, you can add these two called XS, right? Finally, you can write like this. For synchronous impedance, ZS is equal to what? RA plus JXS, right? This is the simplified function, or synchronous impedance, simplified one. And if I ignore the resistance, so what it will be? It will be reactance diagram, right? This is the impedance diagram. This is the reactance diagram. Understood, everyone?
Yes, sir.
Okay. This is for motor. This is for generator. This is for motor. One generator. This is one motor. Okay. Now the transformer. হ্যাঁ বলো
স্যার RGS এখানে যেটা দিলেন স্যার একটু উপরে স্লাইডে স্যার RSS যেটা স্যার এটা কি স্যার এখানে RA যেটা সেটা স্যার
হ্যাঁ ওইটাকেই বলা হচ্ছে সিনক্রোনাস জেনারেটর। ওই আর্মেচার কি বলা হচ্ছে সিনক্রোনাস জেনারেটর, আর এটা হচ্ছে সিনক্রোনাস মেশিন, সিনক্রোনাস মোটর। ঠিক আছে, ওই কিছুই না, আর দুইটাই একই, both are same actually.
ওকে স্যার।
Now the transformer. The definition of the transformer is the static device which transforms the electrical energy from one circuit to another circuit without changing the frequency. That means this is an magnetic device. Magnetically, this will transform energy from one circuit to another circuit without changing the frequency and without reducing or increasing the power. Okay, understood? You already know what is transformer, right? Yes. Okay. Now these are the feature of the transformer. You read it by yourself. Okay, this is for your self study. You can read it by yourself. I can ask you what are the feature of the transformer in the question, but you can read it by yourself. This is pretty self-explanatory. You can read by yourself. Now, the main components of the transformer: the magnetic core, primary and secondary winding, insulation of the winding, lead and tapping for the coil and with their support terminals and the terminal insulators, tank, oil, cooling arrangement, etc. Now here are the applications of transformer: step up, step down, electrical isolation, impedance matching, link between AC and DC system, instrument extension, a lot of things. Classifications of transformer based on number of phases: single phase transformer, three phase transformer. Based on relative position: core type transformer, shell type transformer. You already know. Based on number of windings per phase: one winding per phase, two windings per phase, three windings per phase. Based on the volt, ampere and voltage rating: low voltage transformer if it is less than 1.1 kilovolt. Medium volt transformer if it is more than 1.1 kilovolt and less than 11 kilovolt. High voltage transformer, VHV, if it is more than 11 kilovolt, high voltage transformer. Understood?
Yes, sir.
Okay. The transformer you use in your lab, those are all low voltage transformer. Okay?
We already know that.
Okay, you already know it. These are pretty simple things. So these are all from your machine course, right? And you read it by yourself. I'm not going to go through all of these. Okay, now here, this one you may know or may not know. Current or series transformer, CT. You know it? CT?
Yes.
Current transformer for measuring the current. Okay. Used to measure the current in high current AC circuit with low range ammeter. That means, let's say you have an ammeter, right? That ammeter can measure up to 30 ampere. How much?
30 ampere.
30 ampere. Now, if you have a line, power line, there 1000 ampere of current is going, or around 1000 or 900 or 800 ampere. How can you measure that huge current with your low range ammeter? Can you measure it? You cannot measure that huge current with your small low range ammeter, right? You cannot. But there is a way of doing that. That way is using a transformer, current transformer. If you use a current transformer in that line, that the current will step down to less than 30 ampere. That time you can measure the current and you can multiply that result with that factor, right? Understood?
Yes, sir.
So step up the voltage, step down the current. As the primary coil with one or more turns of thick wire connected in C. Okay, you can read it by yourself. Okay, here normally the current ratios are 100:5. 100:5. That means 100 ampere current becomes how much? 5 ampere. 100 ampere of current become how much? 5 ampere. So if you measure 4.5, so how much? What is the ratio here? 20, right? 20 times. So if you have a 100 ampere current that is going through this wire, now using a current transformer, you can reduce it to 5 ampere. Understood? Now you can measure it using any what? Using any ammeter. Now after measuring your after measuring your current with your ammeter, you got 4.5 ampere of current, right? In your ammeter, you got 4.5. But it is what? It is 20 times less, right? So you have to multiply that with 20. So that will be your final result. So this is the work of current transformer. You can read it by yourself. This is a current transformer things. This one current transformer. So this is have you ever seen clamp meter? Clamp this meter? Have you ever seen this meter?
স্যার গত সেমিস্টারে পড়া হয়েছে
clamp meter দেখছো না? Clamp meter দেখছো না? There is a current transformer inside. Okay, there is a current transformer inside. So it measures the current by holding it, right? So this is exactly what current transformer does. This is a clamp. See, clamp type and clip-on type. This one is what? This one is a clip-on maybe. This one is a clamp. Understood? So,
yes,
so you read it by yourself. I'm not going to go through it. I have to finish the equivalent circuit. Okay. Now the equivalent circuit of the transformer. This one is important. Now here, a transformer is drawn like this. A transformer is drawn like this, right? And this is what you have here, an equivalent circuit. Because transformer has various resistance and reactance. Number one is R1. Number two is XL1. Number two is RC, XM. Here in the secondary side, you have XL2, R2. And the voltages are E1 and E2. Finally, your voltage is V1 and V2. Okay, let's say, let's clear this thing up and see what does it mean. X1, XL1, I1, V1, E1. These are your primary side resistance, leakage reactance, current, voltage, and counter. Counter EMF. Counter EMF is back EMF. This is called self-induced EMF, respectively. R2, XL2, I2, V2, E2. These are your secondary side resistance, leakage reactance, current, voltage, and counter EMF, respectively. RC or R0 or RM, whatever you say. RC equal to R0 or RM. XM or X0 is called core resistance. Core loss resistance. This is called core loss resistance. Mutual impedance. This one is called mutual impedance. Mutual. Remember this thing you will hear a lot of time. You will hear a lot of time. This thing you will hear a lot of time. Mutual impedance. Mutual inductance or mutual impedance. Mutual.
Mutual inductance কি স্যার M দিয়ে প্রকাশ করা না স্যার?
M দিয়ে প্রকাশ করা হয়। M. Mutual impedance or mutual inductance, whatever you say. This mutual word you will learn a lot of things. Mutual means basically these are actually shared, okay, in both sides. So in one side you have to show it. In primary side. Now here, IO, IMU or IC or and IW, these are actually no load current, magnetizing current, and working or core loss current respectively. Now let's go back. So what you have to do, what you have to understand from here, in place of a transformer, you have to write these, okay? In place of
সার্কিটটা অনেকবার করছি কিন্তু বুঝতেছি না, একটু ইয়ে করে প্রথম থেকে বুঝাই স্যার।
আচ্ছা, তোমাকে যেটা করতে হবে সেটা হচ্ছে যে তোমাকে এইটাকে ওই simplified diagram এ তোমাকে জাস্ট একটা ট্রান্সফর্মারের জায়গায় এটা ইউজ করতে হবে। You have to use this whole circuit in place of the transformer. Okay?
Yes, sir.
Now the impedance diagram from the transformer, the impedance diagram কেমন হবে? So you have to do what? Impedance. Is there anything that you can add? Is there any resistance, series resistance or series impedance? No, nothing, right? What you can do? You can actually add these two. You can connect them. Okay? You can connect them like this. So you have what? You have R1, XL1, XL1. You have RC, here RC. You have XM, you have XM. You have XL2, you have XL2. You have R2, you have R2. And anything else? Nothing. So that's why it is called mutual, because they are shared in both sides. Got my point? বুঝতে পারছো?
Yes, sir. Yes, sir.
Now the neglect the core loss. If you neglect the core loss, that means your RC, because your RC is very large. Because your RC is very large, so that means your IC and IW is very, very small. So we can neglect it, right? We can consider this as an open circuit. So we will neglect that. So you have only what? XM, right? Neglecting the core loss. So we neglect. Then what? The reactance diagram. Assuming XM is very large, this XM is also very large. If we assume it, what will happen? This will be open circuit, right? Now what we have? XL1, XL2, R1, R2, right? Only these four. So R1, XL1, XL2, R2. Finally, what do you have? Finally, you have RT, that is what? We R1 and R2. XT is equal to what? X1 and XL2. XL and XL2, right? Remember, these two will be added and will become XT. These two will be added and will become RT. So this is your simplified impedance diagram. Now, if you ignore the resistance, what do you have?
Only reactance, sir.
Simplified reactance diagram or only reactance diagram. So this is what we have to go, what we have to find out. Do you know why we are simplifying the whole thing to these? Do you know? Because all of our math in our future, all of our math will be in reactance. Got my point? All of our math, আমাদের যত ম্যাথ আছে সব ম্যাথ গুলোকে আমরা হচ্ছে রিঅ্যাক্ট্যান্স দিয়ে করব. That's why you have to convert a big circuit to a smaller one. Understood?
Hello, sir.
Okay.
Hello.
Hello.
স্যার ওই যে স্যার সিম্পলিফাইড ডায়াগ্রামটা স্যার ওখানে স্যার ওটা আসলো কিভাবে স্যার?
কোনটা?
এই যে যেটা স্যার। জি স্যার।
এটা এই দেখো এই যে R1 এবং R2 এরা সিরিজে আছে, সিরিজ। এইজন্য এরা যোগ হবে। এই XL1 and XL2 এরা সিরিজ আছে, এইজন্য এটা যোগ হবে। যোগ হয়ে এরা একটা হয়ে যাবে। বুঝতে পারছি?
জি স্যার।
এটা হচ্ছে আমাদের প্রাইমারি সাইড V1, এটা হচ্ছে আমাদের সেকেন্ডারি সাইড V2। ওকে?
জি স্যার।
আচ্ছা। Now, okay, কে যেন শব্দ করতেছো? Okay. Now this one is high voltage or high tension side impedance referred to low voltage and low tension side impedance. This is our per unit calculation. This is our whole per unit calculation. We will do it later. That means in our next class, not now. So you do not have to worry about this. Let's go for the calculation. Not this one, not this one. Yeah, transmission line. Representation of transmission line. So you have transmission line of three types. Number one, short transmission line that is less than 80, medium transmission line that is more than 80 kilometer to 250 kilometer, and long transmission line which is more than 250 kilometer. Understood?
Yes, sir.
Yes, sir.
Okay. Now transmission line can be simply represented by what? An R and what? L, reactance, right? And resistance and a reactance. So this is your total impedance. So now shunt conductance or admittance. This is not conductance, this is admittance actually. Conductance is not a good word. Admittance is a good word. Admittance. What is admittance? Admittance is the conductivity of that line. Okay, now.
Reactance.
Yeah.
Now, impedance.
Now, if your transmission line is medium or long, you have to represent your transmission line using pi model or T model. Pi model or T model. What is a pi model? Pi model is this one. So you have an R, you have an X, then you have what? You have your half admittance, and half susceptance, Admittance is the opposite of reactance. Susceptance is the opposite of impedance. I made a mistake. Admittance is the opposite of what? Opposite of resistance. Susceptance is the opposite of reactance. Both of them will become Y. Y is the what? Y is the admittance. Okay. Finally, Y is called admittance. You can call it. So here you have what? You have resistance. You have capacitance, resistance, capacitance. These are actually called what? These are actually called
admittance.
Admittance. Why actually finally called admittance? Now this is your pi model. What is a pi model? Pi model is something like this. Pi model is something like this. Understood? In your series, you have your main component, and in your parallel, you will have your other component. Now this is called pi model. This is
connection.
No, this is called pi model. Pi model if you have in your VLSI, if your 11th semester, you will learn about pi model and T model as well. In VLSI, you will see normally the wire or cables, understood, right? Cables are analyzed. Cables are analyzed using T model or pi model. Okay. So transmission line is also a cable, right? Is also a cable. Cable has resistance, cable has capacitance, cable has inductance. All of those you have to represent in your circuit. তুমি বলতে পারো স্যার কেবলের রেজিস্ট্যান্স কত? না, no. There are resistances in your cable, right? If there are resistances in your cable, and if the cable is long enough, then you have to what? You have to address them, or you have to analyze them using a model. This model is called pi model or T model. Sometimes it is called L model. So L model is not important. L model is not good enough for analyzing. Pi model is very popular. T model is very popular. Pi model means you will have a component here, you will have a component here, and you will have your main component here. See, the main component is here, and you have something here and something here. That's why it is called pi model. What is T model? T model is here you will have something, here you will have something, at the middle you will have something, right?
Yes, sir.
Okay, let's take a 1 minute break or 2 minute break, okay?
Okay, sir.
So এখন একটা জিনিস তোমাদেরকে দেখতে হবে, সেটা হচ্ছে যে what you have to do, what you have to see, that is how the components are divided into pi model and T model. See, in your transmission line you have one R and you have one X. In your pi model, they are used in one place only, that is at the middle. So the all of them will be there, so R and X. But this part is twice. This thing you have to write twice, right? So that's why you have to divide them. So you have to divide the whole G and whole B by 2. So your G by 2 will be here, B by 2 will be here. Your G by 2 will be here, B by 2 will be here. So that means your Y by 2, this is your Y by 2, this is your Y by 2. Okay? In your next case, you see, in the T model, you have to use your main component twice. Main component means main resistance and reactance twice, right? So you have to divide the R by 2, X by 2, R by 2, X by 2. Understood? This thing is divided into 2 parts because they are used in twice. They are used twice, right? This thing is divided twice. divided by 2. That means they are used in two places. Understood? But this one
Yes, sir.
is used once only, once. Since they have been used once, so G will be G, B will be B, so the total is Y. Understood? So this is how your T model and pi model are seen. So in your question, I might say use pi model for transmission line or use T model for transmission line. Understood? I can ask. Okay. Now this is the long transmission line. It is more than 250 kilometers. This is the long transmission line. I'm not going to go through all of it. Not needed. So equivalent pi model or pi circuit for long transmission line, you have already seen. Pi model means what? This one is Z, this one is Y by 2, this one is Y by 2. Okay? This is the pi model, right? You have a Z, that means R plus X or JX, whatever you say. And this one is what? This one is the Y by 2. This one is Y by 2. So three things. One is this one, another one is this one, another one is this one. So this is your pi model. So both of them are same thing, just the slightly value difference are there. So now one line diagram or single line diagram, that means OLD or SLD. The things I have already told you. The one line diagram or single line diagram is a simplified notation for representing a three-phase power system. That means a three-phase power system will be represented by an one line diagram. This one will be N, not A. This one will be N. And one line diagram or a single line diagram. One line means three phase. Remember, one line means three phase. It can be single phase as well. The simplified diagram of an electrical system is called one line or single line diagram. I can ask you, what is one line diagram? Okay. The purpose of the one line diagram is to supply in concise form the significant information about the power system. That means a lot of things are represented in one line diagram in a simplified or a concise form. Concise means simplified. Concise word means simplified. মানে ছোট করে দেখানো হবে। মানে বড় একটা জিনিসকে ছোট করে তোমাকে উপস্থাপন করানো হবে। Miniature. Okay? That is called one line diagram. So you can read it by yourself. Now, why one line diagram? Power systems are extremely complicated, extremely. Geographically spread system and three-phase system, these are actually what? These are actually simplified and represented in a single line diagram. By watching that, you can actually understand, okay, what is there, what is there, what is there, how far, or where is your transformer, where is your circuit breaker, where is your fault, where is your generator, where is your motor, how many generators do you have? You can look at your one line diagram and you can have a guess. Understand? Okay. Now, what are the symbols and apparatus? So you have to know which one is which. The round thing, that means the circle, is a machine or rotatory armature. Circle is a machine, that means generator or motor. Okay? Generator or motor. So how do you know it is generator or motor? G and M. Okay? G will be written or M will be written. Understood? Okay. This one is a circuit breaker. This one is a what? Circuit breaker. This one is a what? Can anyone say? Transformer. Exactly. This one is a what? AR circuit breaker. This one is a what? This one is also a transformer. What type of transformers? This type of transformer. Two windings, primary and secondary. Okay? Two windings transformer. This one is a transformer. This one is also a transformer. You have to know which one is which. Okay? This one is a what? This one is a three winding power transformer. This one is a what? This one is a delta connection. Delta connection. This one is a Y connection. This one is a fuse. Okay?
Y connection.
Okay. Understood? Okay. Let me show you something. I'm going to stop the recording for a second. Pausing. These are the apparatus symbols. This one is a current transformer. This one is a potential or voltage transformer. This one is a Y connection, three-phase Y connection with neutral grounded. This one is grounded. This one is also grounded. This one, three-phase Y connection, neutral is grounded through a what? Through a reactor or through a resistance. Okay. This is an ammeter. This is a voltmeter. Now, detailed impedance diagram. Detailed impedance diagram. Let's do an example. This one is a very simple example. 2-bus system. You have one generator, then you have a transformer. This one is a delta Y transformer. This one is you have a transmission line, you have a motor, and you have a load, right? For generator, you have to use what? You have to use these, right? Remember generator? Resistance, reactance, and EG1. Okay. Then for transformer, T model. This is a T model, right? This is T model, right?
Yes,
Resistance,
yes,
reactance, and at the middle you have Y, right? So this is your T model. Then what? Then you have a transmission line. Then you have a what? Transmission line. Transmission line is, this is the pi model, right?
Yes, sir.
Why pi model? Because they didn't mention anything, so that's why we have put pi model. Because this part and this part, they will be ignored eventually, right? If they are ignored, you have only one thing, one R, one X. That's why this is your transmission line. For motor, this is your motor, right? Like a generator, you have reactance, you have resistance, and you have what? A circle. Now for normal load, the load can be okay, this is called RL load. That means you have a R, you have a what? You have an L. RL. Can you see that? Yes. So this is your simplified, no, detailed, not simplified. This is your detailed impedance diagram. Detailed impedance diagram. Now simplified impedance diagram. How? Ignore this. Ignore this. Ignore this. Okay? Then add these two. Add these two. Okay? So what do you have?
Yes, sir.
What do you have? You have a generator here. You have a transmission T1, that means your transformer. Then you have TX line, that means transmission line. Then you have a motor. Then you have a load, right? Now,
Yes.
in this lecture, you do not have to put any value. You do not have to put any value. The value will be put. The value you will be calculating in your next lecture. That is called per unit calculation. Here, they will say, okay, simplify these and draw the impedance diagram, right? After saying a lot of things, they said draw the impedance diagram. That means you have to draw the impedance diagram. So this is your impedance diagram. This is your impedance diagram. This is your impedance diagram. This is your reactance diagram. Here, can you see some values? Can you see the values? Hello?
Yes, sir.
Okay.
Yes, sir.
At first, you do not have to worry about value. The value will be added after this lecture, okay? So right now, no value. So this is your what? This is your simplified impedance diagram. What about reactance diagram? Can anyone guess? Ibrahim, Shuaib, Saidul?
Yes,
Yes,
sir.
sir.
What about the impedance diagram, reactance diagram? How can you convert this to reactance diagram?
So only use the reactance.
Exactly. So resistance will be gone, right?
Yeah.
All the resistance will be gone and we will have something like this. Got my point? Now here they have done one more thing, that is they ignore the load, right? They also ignore the static load. They also ignore the static load. That means they ignore what? They ignore these and as well as they ignore these. Understood? So all resistances will be ignored. All static load means RL, RC load will be ignored. The magnetizing current The magnetizing current of each transformer will be ignored. All capacitance of the transmission line will be ignored. So transmission line capacitance is already ignored. If it was not ignored, it will be ignored here. Okay? Got my point? Buchcho tomra? Got it?
Yes, sir.
স্যার রেজিস্ট্যান্সটা না থাকলে স্যার রিঅ্যাক্ট্যান্স ডায়াগ্রাম স্যার
হ্যাঁ, রেজিস্ট্যান্স না থাকলে রিঅ্যাক্ট্যান্স ডায়াগ্রাম, এবং তোমাকে ওই যে লোড গুলো বাদ দিতে হবে। ইফ ইউ হ্যাভ লোডস, লোডটাও বাদ দিতে হবে। Okay, this is your reactance diagram. Got my point?
Yes, sir.
Okay, let's do one example. All of you do these at your home, okay? All of you take a screenshot. You took the screenshot? Hello?
Yes, yes, sir.
Okay.
We take.
Do not